restrooms, as you go out of this hall, you turn to the left, and then you turn to the left again, the inside of the building. The very first toilet is the gents' toilet, and the next one next to it will be the ladies' toilet. If you need to use the restrooms in the building. Thank you. Good afternoon, ladies and gentlemen. I would like to welcome you to the Students' Paperettee competition for the year 2017. My name is Paperettee from the Faculty of Engineering, and I would like to especially welcome those who are not from the University of Zimbabwe, who have come to be with us today. Let me start off by first of all recognizing the presence of the Vice Chancellor, or the Pro-Vice Chancellor, who is in our midst. I also want to recognize the presence of our guest of honor, who I will introduce to later, Dr. Nachegete from the Postal and Telecommunications Regulatory Authority of Zimbabwe. If there are any who are professionals of industry, I'm aware that some were invited to come and attend this function. Unfortunately, I haven't been given all the names, but please feel welcome. We would like to welcome you, and please feel free to participate and actively enjoy the proceedings this afternoon. I'm aware also of the many chairpersons and the many leaders, and specifically I want to mention the presence of the Dean of the Faculty of Engineering, who is here with us, as well as the Deputy Dean. I also want to recognize all the students who are here, who have come in their numbers, and I'm sure it makes the whole event exciting, and we should have a very good afternoon of seeing some of the activities that have kept you busy during the time at this university. But maybe amongst the students, may I specifically mention the 7 students who will be presenting, and these will make our day today, and in a short while they will be doing what we have all gathered to see and hear of the work that they have been doing. I am also aware of the people who have been organizing behind the scenes all the activities that have led to this particular event, specifically our organizing committee, which is chaired by Engineer Mushira. I can't see him, but I'm sure he's somewhere in the house. And I'm sure they have been doing quite a lot of work towards the hosting of this event. Maybe to kickstart our function this afternoon, we will have, according to our program, I don't see anything which is like a public board where we can actually see what will be happening. But I'll just run you quickly through what will be happening this afternoon. Shortly we'll be having our welcome remarks from our Vice Chancellor, the Vice Chancellor of the University of Zimbabwe. Thereafter we'll have just some of the rules of what actually is happening here, and I'll invite someone from the organizing committee to give us exactly how the proceedings will go on with reference to the presentations by the students. Then thereafter, there will be the actual presentations themselves in the order that is given in the brochure that I've been given here. I assume this is alphabetic. There is nothing special about it. It's just an alphabetic listing of the departments of engineering that will be making the presentations. Shortly after the presentations, our judges will have their time to assess those presentations by the students. And during that time, we will have what I would call a commercial break, where we can have some presentations from some of our sponsors. And when the judges are ready, they will come up. And before they do, there will be a presentation by our guest of honor, as I said, Dr. Machengete from the Postal and Telecommunications Regulatory Authority of Zimbabwe. And following the presentation by our guest of honor, we will have the judges to give their credits on the presentations by the students. This will be followed by the presentation of prizes by the guest of honor. We have included something because the judges will be doing this work who need also to be recognized at some point. And at that stage, I'll be asking the chairman of the organizing committee to come up front and to present a token of appreciation to those judges who will be doing some of the hard work this afternoon. And because of our activities this afternoon, I will invite the Dean of the Faculty of Engineering, Dr. Makurira, to come up and give closing remarks as well as the vote of thanks. That is how we'll proceed, and then of course, after the function, we are all invited to refreshments which have been provided specifically for this function. I think without further ado, I'm just going to ask the Dean of the Faculty of Engineering to come up front and also to welcome our Vice Chancellor so that he can give the opening speech for this occasion. Thank you, Dr. Mukuri.
Good afternoon, ladies and gentlemen. I would like to welcome you to this competition organized by the Faculty of Engineering Association with Zimbabwe Institution. My task is very simple. Dr. Shidori has done the introduction of everybody else except the owner of the house. So it's my pleasure and honor to invite and welcome and invite the Pro-Vice Chancellor Academic Affairs to give the welcome remarks.
Director of Ceremonies, Dr. Shidori, our guest of honor, the Director General of the Post and Telecommunications Regulations Authority of Zimbabwe, Portras, Dr. G.K. Machengete, the representatives of the Zimbabwe Institution of Engineers here present, members of the University Executive who might be here, the Dean of the Faculty of Engineering, Dr. Paperettee, and other deans who might be here, directors of institutes and centers, UZ, Engineer Guri from Zera, Mr. Matsika from Zimbabwe, Dr. Gloria Codswell, who is the benefactor of National Engineering Students Awards Competition, our esteemed judges, captains of industry here present, our esteemed judges, members of staff in the Faculty of Engineering, and colleagues from industry, our contestants, our students, members of the media who will be here, invited guests, ladies and gentlemen. It is with great pleasure that I wish to welcome you to the University of Zimbabwe this afternoon to witness our 27th edition of the University of Zimbabwe Student Paperettee competition, which has been organized by the Faculty of Engineering together with the Zimbabwe Institution of Engineers. And we are grateful that there is an organizing committee that has been working tirelessly to put together this historic event, which has become part of our annual calendar. And the level of excellence is reflected by the trophy that is on the item which our students won in the national competition. So can we give a round of applause? This is an opportunity to allow our students to display their ingenuity, their research and creative potential, their highly innovative mind. And we are very happy that this is evidence of the future innovators and inventors that the university is producing. Ladies and gentlemen, guest of honor said, the University of Zimbabwe is shifted from a highly, theoretical curriculum to an applied curriculum, where we are following the agenda that has been set by government in line with the program of the African Union. And the African Union's program is for industrialization and modernization, which is part of Agenda 2025 as well as 2063. And so the university is transforming its curriculum so that it's in tandem with Agenda 2063, where Africa is driving its own agenda for modernization and industrialization. And modernization is different from westernization. Guess what? There's a tendency to correlate modernization with westernization. But the fact that in every 48 hours there is a McDonald's being opened in some part of the world, it does not mean that that is modernization. Modernization takes a contextual flair. It is a development where a nation develops with the help of technology. And sometimes technology is homegrown, or it's adapted after being adopted from another context. So as part of modernization, we are saying to industry, while we are grateful of the collaboration that we have always enjoyed from industry, and as you know, historically, the Faculty of Engineering has always benefited from the support from industry, particularly the Institution of Engineers, either in terms of student scholarships, various type of academic-related support, and also infrastructural development. But what we are aiming at is not just to celebrate the academic and research results deriving from that support, but we are saying we need to go beyond mere creativity and innovation. We need to adopt a new paradigm or new model of development, where we are development-oriented and product-oriented. We must now emphasize new paradigms that follow the trajectory of applied research. There is lecture material that students get, and from the lecture material we have what we call applied research. And from applied research we have innovation, and from innovation we have enterprise. We have another model where we have applied research. From applied research we have innovation. From innovation we have solutions. From solutions we have enterprise. So it is important to adopt this kind of developmental trajectory, because Africa is saddled with problems of a developmental and a survival nature. And yet we have the highest literacy rate in Africa is Zimbabwe. We have a lot of creativity and innovation that is deriving from academic excellence. But very few of those innovations end up with as products or enterprises that make a difference in people's everyday life and experience. So what we are aspiring for is an academic curriculum that results in research, innovation, and creativity, which also then results in solving problems that people experience in everyday life. And after those problems have been solved, we now have enterprise. We have people having commercialization of those products. And then you make money after that. Our aim is to try and follow the example of the University of Stanford, where you have the Silicon Valley, model. And you have Google, you have Microsoft, you have other enterprises that are arising from academic ingenuity and creativity. And you have examples across, Asia, Southeast Asia, you have Malaysia, you have India, you have South Korea, you have Japan, and you cross over into Cuba and then Brazil. Those countries have developed, and including China of course, mainly because their academic curriculum has been tailor-made, to achieve something that makes meaningful contribution to people's everyday experience. So if we celebrate the creativity and the innovations that our students are producing now, and we do not have meaningful support from industry to make sure that those innovations are developed into problem-solving tools that will then, result in enterprises which the students themselves will be able to live from, and then will be able to employ, other people and then the country develops through that model or that trajectory. So we are appealing to industry, academia, and government to participate in a kind of tripartite arrangement or tripartite relationship, where, of course, funding is mobilized. And when funding is mobilized, the universities, together with other universities and higher tertiary education, are working towards an incubation system or structure, where University of Zimbabwe will have an incubation center, to try and catalyze or stimulate, innovation that ends into problem-solving tools and enterprise. We are also at a moment where we are talking to the Ministry of Higher and Tertiary Education, Science and Technology Development. In fact, they are initiating a very robust and important, program of developing an intellectual property law. At the moment, the country has no intellectual property law. You know as much from your industry, guest of honor, that is a very critical, legal instrument. At the moment, we have a copyright law, which is making a huge difference, although, of course, we are struggling with, what do you call it, piracy, continuous piracy. And because of the level of poverty in academic institutions, there is rampant photocopying of unauthorized material. And so the creators of those, innovations are getting very little, if anything, from the sweat, of their creativity. But I'm sure once we have an Intellectual Property Act, it will then assist, to motivate, because a lot of innovators are discouraged by the absence of such a legal instrument. And so we are hoping, guest of honor, that the performance or the creativity and innovations that our students are displaying this afternoon will not just be a talk show that will end, today. We are hoping that industry, academia, and government will join hands to get funding and to nurture the young and growing creativity, so that, as I said, it will develop into an incubation process that will result into problem-solving, culture. And of course, we grow enterprises. Once we grow enterprises, we begin to industrialize. And the homegrown industrialization is more sustainable than, imported industrialization. I know we cry for external investment, and we cry for funding, coming from World Bank, IMF, and so on, to stimulate, local industrialization. But the moment we ground the industrialization in our own innovation, in our own talent, in our own academic, talent, that kind of industrialization is guaranteed to be sustainable. So, guest of honor, ladies and gentlemen, I wish that today's function will become a learning camp to everyone. And I hope that from next year on, we will begin to see an increased number of participants. We will also begin to see a more gender balanced, team of participants. We don't want it to continue being theoretical and political. We want to see more gender balance. And I hope that as we develop our faculty of engineering team, we will now see a more gender balanced faculty, where we see, more women engineers coming up to join the faculty team. And when that happens, we spread the scale and scope of creativity. because there are innovations that are done by women, because they, by nature, are born with that intuition to innovate in a certain direction. There are also innovations done by men, because by nature, the intuition, of course, to develop in a certain area. And so let's replicate an African family situation, not the Western, family institution, where it's possible to have a mother and no father, or to have two fathers, one claiming to the mother, and so on and so forth. So, guest of honor, ladies and gentlemen, I wish you all the best, and I want to hope that we will have a very memorable, occasion. Thank you very much, and good day.
Thank you very much, Professor Chancellor, for those fitting words. And I think it goes without saying that this is indeed a very special occasion for these 7 young people when they listen to what you just said. Actually, I was provoked when you were referring to the emphasis of application of whatever it is that there is ideas. Sometime earlier on this year, I attended a conference in Europe somewhere where I'm going to represent some activity. And I was pleasantly surprised in this global conference because it happens to be hosted by the same people who helped me when I was doing my own studies. And they were invited a very provocative old man called Nolan Bushnell. I don't know whether anybody in this room would know who Nolan Bushnell is, but he had a very interesting story to tell, and I think it will relate to some of the exhibits that we have today. Before I forget, the organizers have done it in such a way that just outside the doors here, you can actually see the posters of the presentations that you'll be seeing today. Now, Nolan Bushnell happens to be a young man who grew up in California. I think they were in the same class dropout with Steve Jobs. He started working from his garage at his house, and sooner or later he had developed something which he, at that time, didn't know how powerful it was. He was the inventor of the Atari games. And today, as we speak, there are very few games which are there worldwide which do not have an input from Nolan Bushnell. He tells me that at some point when he was building up his first trick of whatever games he wanted to present, he had a colleague whom he hired as a helper in his garage. This guy turned out to be Steve Jobs. He was doing some jobs for Nolan when they were trying to build some games which he knew he could mass produce. And at some point, I think Steve Jobs got clever. And he went to Nolan and said, listen, I think I'll leave your company. I want to go and start up something on my own. And those were the early days of microprocessors and simple computing tools. And Steve Jobs went also to his own garage and started up something. And when it started catching fire, he went back to Nolan and said, Nolan, can you come and join me and buy 50% of my company? But Nolan was already established as an Atari distributor. And he said to Steve, sorry, I can't take it. I am too busy and I've got something going on for me. And Nolan was saying he regretted the day that he turned down the offer that he gave to Steve Jobs. Because from that time onwards, Steve Jobs grew in leaps and bounds, and he today still is a household name when it comes to computing. What I'm trying to say here is, we have young students, we have young minds, talented minds who are here. And I would like to introduce to you these 7 young minds that we have today. There is Rubinzai Tumbe, who is going to be kickstarting our proceedings shortly. There is Confidence Fellow, Gerald Chikoi, Godfrey Mushana, Tatenda Nyawai, and Konimzashe Ndagana. These are the young people who will be today giving us some of the results of their work during the last year or so. And before we go any further, the committee has some very specific rules of procedure. I was going to invite Engineer Michelle. I can't see where he's sitting, because I would like them to come up and just give us some idea of what kind of rules. I can just give you the general background so that we stick to this one. Basically, a presentation is 15 minutes, and following the presentation, there is 5 minutes for Q&A. So, I would like to alert the 7 presenters. You will be timed, and it is strictly 15 minutes and no more of presentation. I would like you to watch out. There is a timer which will be put up on the screen to my right and to your left, where you will be clearly told how much time you have and how you should probably wrap up your presentation. There will be no additional minutes given after the 15. There will be time for questions, and to the audience, questions, please limit your questions to 1 question and no repetition of questions. And try and not lecture to the presenters, but please just explain exactly what your contribution is or what your question could be. Thank you very much. I don't know whether there's anything that I've missed out to the organizing committee. Is that good enough in terms of rules and procedure? I think we'll get started now. It's okay. Perfect. Right. So, ladies and gentlemen, allow me to invite to come up front our very first presenter from the Agricultural Engineering Department. And it's Rubitai Lube. Excellent. So we are all here. Just trying to sort out the technology. We should start right now. it is the best we can do. You will have a problem with you guys doing the recording. Is that better? Yeah. Okay. All right. Thank you.
Due to the increase in our population growth, we now have an increase, the volume of the waste that we're generating is increasing at a faster rate than the local authorities' ability to improve the financial and technical resources that are required to parallel this growth. Due to this increase in the quantities of waste that are being produced, we've now had a depletion of our landfill capacity, which has led to people turning to other ways of waste disposal. The current ways of waste disposal that are now being employed by people are open dumping, as can be seen in the slides that appeared first. And this open dumping is posing serious public and environmental risks. As we recently had an outbreak of typhoid, which was as a result of such practices of open dumping, because as you can see, small children are found sometimes playing amidst the waste that is disposed of in the streets. Also, our mining industries tend to generate vast quantities of coal dust. They are producing 0.3 tons of coal dust per ton of marketable coal, which is then disposed of, and this coal has been seen to be an environmental nuisance. This coal is causing land and air pollution, and we know that coal is carcinogenic and it's depleting our air quality, and it has led to such diseases as cancer. And also, when this coal dust is blown by the wind onto fields, it deposits on leaves, and then this has led to the reduction in the growth of some plants. That's why you'll see in areas where there is coal mining, we normally have stunted growth of our crops. Due to this population increase that I alluded to earlier, we've had an increase in the energy demand. The energy demand in Africa is increasing by 4%, as concluded by the International Energy Agency. What is the solution to this problem, ladies and gentlemen? The solution is the development and evaluation of the high-energy solid fuel from admixtures of coal dust, bio-waste, and post-consumer plastics. Admixtures, by definition, are mixtures in which the entities mixed retain their original properties. My name is Rufizai Aslume from the Department of Agricultural Engineering, and I did my project under the supervision of Professor W. Kwenzi and Mr. Tiru Kwenzi. To justify this project, utilization of this waste in the production of a solid fuel is going to lead to environmental and socio-economic benefits. We are going to have a reduction in the public and environmental risks that are associated with the disposal of this waste. Also, we're going to have value addition to such crops as maize and tobacco, which are currently added to the amount of bio-waste that are being deposited in our landfills, and also which are being openly dumped. Because when we produce these crops, we're going to produce them for the maize and the tobacco that we want, and also have the chance of utilizing the waste so produced. We're also going to have creation of employment, which will lead to economic development, which is in line with the Zimbabwe strategy of exterminating poverty. Also, we're going to have a reduction in the costs that are being incurred by processing industries in the disposal of their waste. The objectives of this project were to determine the optimal mixed ratios of the waste that would yield the best combustion and handling properties, to develop the high energy solid fuel from the waste, and then to evaluate the physical and mechanical properties of the solid fuel. The solid fuel was produced using the process train that is shown. Material selection was done, which was then followed by site reduction of the materials and formulation of the mixed ratios. after which a binder was added and the briquettes were produced by compression of the mixture. The briquettes were then cured in open air for 7 days, and then the evaluation of the solid fuel was done. The materials used were coal dust, sawdust, and PET plastics, using molasses as a binder. The sawdust produced was obtained as wood shavings from the mechanical engineering workshops, and then it was data size reduced to obtain a 2 mm size sawdust. The coal dust was obtained from Krogel, and then it was sieved to obtain also 2 mm. The PET used was obtained from the UZ waste dump, and then it was size reduced and packaged for Zimbabwe into the usable flags that are shown in that container. Molasses was selected as the binder due to the fact that it is relatively cheap. The other binders that could have been used are starch, but molasses was found to be the cheaper option. The methods employed in the production of this fuel were use of a brick press and use of a briquetting machine. In the use of the brick press, the material was placed inside the press, and then it was compacted by way of applying 10 uniform blows. And then, in the use of the briquetting machine, the mixture was fed into the feed hopper, and then it was extruded through the use of a screw which is inside the extruder. It was extruded as cylindrical briquettes. The outcome of this briquetting process were brick-shaped solid fuels and cylindrical briquettes that are shown on the far end B. After the briquettes were cured for 7 days in open air, they were evaluated. The first test was the shatter index, which is a test that investigates the resistance of the briquettes to mechanical action, which was done by way of dropping them from a height of 2 meters. The minimum acceptable shatter index for briquettes is 90%, and all the ratios used all exceeded that value. The next test was the investigation of the density of the briquettes. All the briquettes had a density that was well above the expected 0.6 grams per cubic centimeter. The compressive strength of the briquettes was also investigated, and the ratio that yielded the greatest strength had a maximum of 0.75 megapascals. The resistance of the briquettes to humidity was determined by measuring the water absorption of the briquettes. The desired water absorption is a maximum of 30%, and we had 2 ratios that exceeded the desired water absorption. So these 2 ratios were discarded, and only 3 ratios were evaluated further for the energy values. The evaluation of the energy values was done at the Institute of Mining Research, and the values were found to be greater than the minimum energy values for coal currently in use. And then the maximum calorific value as recorded was 33.8 megajoules per kg, which is also greater than the maximum values for coal, and is in the same range with calorific values for coal and some liquid fuels. The calorific value of this fuel showed that it has greater energy values than wood, which range between 12 megajoules per kg and 20 megajoules per kg. The energy used to produce this briquettes was a total of 18.9 megajoules to produce a kg of the fuel, and the minimum output was a waste phase of 25.6 megajoules per kg. The financial analysis. The waste that were used in the production of this fuel were all obtained for free, but I had to quantify to use a worst case scenario where I had to buy the waste to produce the 70 kg of the fuel. Using a cost of $10 per 100 kg of plastic and $1 for 50 kg of sawdust, I would have used a total of $55.2 to produce 70 kg, which can be sold at $105, giving a for tobacco curing. And in the past 15 years, Zimbabwe has been in the top 10 countries with the largest forest cover loss. Using this fuel instead of wood will then reduce on the amount of deforestation that we currently have, because we are losing 327,000 hectares of forest cover due to deforestation to get wood to fire our poultry homes and for tobacco curing. Also, we can use this solid fuel in industrial heating applications. The reason why this fuel will come in handy is that the coal dust that is normally produced even in power generation has high energy values, but its use is currently constrained by its gas nature because it clogs boiler pipes and has a risk of spontaneous explosions. So this fuel can be used in place of coal, also as a cheaper alternative. The recommendations are that the combustion properties of this fuel, as well as the effects of briquetting pressure, temperature, and residence time when the briquette so produced can be investigated. The conclusions are that there is potential to scale up this technology so as to add to the energy contribution to meet this rising demand, and also to create potential value chain opportunities. Also, we're going to have a reduction in the current costs that are being incurred by processing industries in the disposal of waste. In line with the Zimbabwe Agenda for Sustainable Socio-Economic Transformation, we'll also have creation of employment which will exterminate poverty and improve the livelihood of many. As you can see in the 4 pillars of the Zim assets, we are going to address the social services and also the value addition, which will lead to the economic development of our country. Thank you.
Thank you, Robin. Time for questions. Any questions? Please. You have the only mic.
Thank you very much. I just wanted to ask the young lady, when you started the presentation, you showed us the mountains of garbage that is manifesting the city. But your solution is using wood shields and PET plastics. And I wonder what percentage of the waste in the city you are going to address with your solution. Yes, it has to be visible results, but I wonder whether it has addressed, the level of waste that we have on those dumps.
We are currently producing 2,000 tons of plastic waste per year. So if we utilize that plastic waste, most of the plastic waste produced is PET plastic. Of the 2,000 tons produced, 0.8 tons is plastic that is in form of PET. So utilization of this PET will lead to a vast reduction of plastic waste that we're currently disposing of.
There's another hand, please. There's one hand.
What I can say is that your presentation is scientifically feasible, but what a person on sustainability, or rather symbiosis of your raw materials, because you say where there is no grass, no yes, vegetation, so they don't stay much here, there's no molasses. So how will this one accumulated
Speak on the microphone.
Okay. Yeah, I hope he heard my question.
Just repeat specifically the question that you had. Thank you. Just repeat.
Okay, my specific problem is on the sustainability, or rather, the symbiosis of the raw materials. When they fall down, vegetation, therefore less the shaping, the country molasses obviously. So how will this now come a mix to be combined together?
Yeah, we're still struggling. Let's see whether she can answer that. Thank you.
I mentioned in the recommendation that SWOP exists to investigate the effects of the pressure. Because I'm assuming if we use higher pressure, like those used in automated briquetting machines, we can eliminate the need for a binder.
I'll take the last question now. Thank you. There's somebody over there. Thank you, Professor.
I found your presentation very stimulating. I've got two very quick questions. First is the problem of garbage collection or the accumulation of garbage. Is it not just a political policy problem that can easily be solved without venturing into this scientific? Then secondly, again, is it not possible that the industrialization it will bring the proliferation of takeaway shops, and then that they will be readily available and within proximity of consumers, and eliminate the count of mobile consumption that causes widespread littering. And then of course it won't be necessary to go into all that scientific process.
To answer the first question, which was sorry, can you please repeat the first question again?
I think, is it just a political and policy, handicap? Because one example was to come with a policy of zero tolerance on use of certain types of plastic. Then, of course, once there is a policy that supermarkets, etc., will not promote, the circulation of certain sizes or gauge of plastic, and then that policy will eradicate completely circulation and, of course, accumulation of that plastic. Would then it be necessary for you? In other words, I'm feeling the viability of your scientific inquiry and project. To what extent can it then be viable if the correct political and policy formula, parameters have been put in place?
The first question was whether the fact that we have vast quantities of waste is deposited any and everywhere. Of course, it is an issue of politics, but also we're saying the quantities of the waste that we're producing, especially the plastic waste, it's consider the packaging materials for electronic gadgets, it's bulky. So while it may be a political issue, we have those bulky plastics depleting our landfill capacity. So even if the politics were to change and we would have the dump sites available, still we are saying our waste is bulky, it's going to deplete our landfill capacity.
I refer to the last question. There's a gentleman over there. Yeah, please, just give him mind. Thank you.
Thank you very much for your presentation. My question is on the price for the product. You mentioned that the farmers who are involved in tobacco are going to benefit from this kind of fuel. How affordable is it as compared to the existing products that are available?
To the local farmer, the reason why I also chose to use a brick press in the production of this fuel was to show that it is possible that a farmer can produce this fuel on his own using a brick press. Most people currently own those things, the brick presses and everything. You can actually produce the fuel using available waste. In the case that we don't have this in place, considering that we're using waste, this fuel is going to cost probably a third of the fuels that are currently in circulation in the market. I'm not sure if that answers.
Thank you very much for your very, very inspiring presentation. We're going to have our next presenter now. I'm going to ask, please, presenters, look at your right hand side. You will see a clock there, which will guide you as to how much time you have. We have someone now coming in from the Department of Civil Engineering, Confidence Fellow.
Good afternoon, ladies and gentlemen. My name is Confidence Fellow, and I'm going to present my project entitled Rainwater Treatment for Reuse at the University of Zimbabwe. That is, my study area was here on campus. This project was done on the University of Zimbabwe. So here are my supervisors, Engineer Zeto and Engineer J. Sereba. So let's just go into it. I will start by defining the term greywater, since this term is appearing on my project title, so that almost all of us will be on the same page.
for the next slide. Okay, grey water was defined by the World Health Organization in 2013 as all the domestic wastewater that comes from the laundry, that from the washing scenes. You can also see this lady, so from the sinks and from the bathrooms, and also the water that comes from the clean wash basins, and also from our kitchens. This smiling lady is washing this sink. So the water that comes out from these sources is what we call grey water. This water does not contain significant concentrations of excreta, and it constitutes between 60 and 80% of domestic wastewater. So why recycle? Why reuse grey water? What's the problem? So from a global perspective, it has been predicted by the World Health Organization in 2014 that by 2020, water shortage would be a more serious worldwide problem, provided the current predicted growth in every centers and population persists. So if we narrow this problem down to our own analysis council, it has been reported by several researchers and authors that analysis council face perennial water shortages since around 2007. Almost all analysts are aware of this. Or as it can be evidenced by this picture, you can see these residents are queuing for water. There's a sink over in the middle there. Due to this water shortage, some vulnerable residents, especially kids, have resorted to unsafe sources of water. You can see these little brothers are getting their water from these polluted sources. Okay, this water shortage was considered to be a major driver for the cholera outbreak, which hit Harare and Zimbabwe in general, resulting in 8,600 recorded cases and 4,300 deaths. This is by the year 2018. This has caused even the Zimbabwean government to declare cholera outbreak a national emergency. You can see this husband is pushing his wife in the Uber. So, other this can go to the northern suburbs and dig their own boreholes due to shortage of water. There you can see this man here drilling with borehole. This picture was taken from one of the suburbs near Nile. But unfortunately, most of the boreholes, or a lot of the boreholes, have been reported to run dry. It is flooded in the media, and a lot of people have witnessed this. So, specifically for the investors of Zimbabwe, let us narrow down the problem again to our own campus. Since 2008, the investors of Zimbabwe has not received adequate in the reliable amount of water from the Harare City Council. And the investor was supposed to close for several months in 2008. The Vice Chancellor is aware of this. This was designed by our faculty of engineering. We are also proud of this. So, but unfortunately, excessive water table drawdown is noted in the sphere of groundwater mining. So, what shall be done? What can we do? I'm recommending grey water recycling companies because grey water recycling comes with a lot of advantages. Benefits of grey water recycling. Firstly, for the investors of Zimbabwe, this will reduce the potable water demand. That is, it will reduce the amount of water which is being pumped from the groundwater source. And also, it will delay the need to develop new and costly water infrastructure for the investors of Zimbabwe specifically and for the country in general. And also, the third advantage is nutrient recovery. Grey water is rich in nutrients. So if we reuse it for irrigation, there will be a very good nutrient recovery. Also, the fourth advantage, it will be possible to connect additional wastewater contributors to the same sewer system in the future without overloading it. That is the pro Vice Chancellor can construct more hostels And those hostels can still feed their wastewater into the existing sewer system without overloading it. Those are the benefits of recycling the water on campus. So these were my the first objective was to assess the visibility of rainwater and flushing the toilet and also irrigating the ground at the University of Zimbabwe. This was my main objective. These are the specific objectives. To determine the physical and chemical parameters of greywater from a selected row of residents and have selected Cassadas. And the second specific objective to design and install a pilot greywater system at Cassadas. Then the last specific objective was to assess the performance of the prototype so as to provide design recommendations for upscaling purposes. So these were the methods which I used for my project. I used a sedimentation tank with a vertical flow biosensor filter. The prototype was in operation for 6 weeks and it was saved 28 students. And also selected water quality parameters were tested at intervals down through the prototype. So how the prototype was operating. From my method, everyone saw that there is a sedimentation tank and a biosensor filter. So these were the two major components of my prototype. Those blue lines show the flow of wastewater from the end point up to the exit point. So this is how my prototype was operating. The raw water entered through this inflow pipe and with time due to soap and detergents which are being used by the students at the hostels. With time, a scum will develop and also sludge will develop due to the suspended solids from my wastewater. And also after circulation, the water will then move to the vertical flow biosensor filter. The head of the supernatant at least 800 millimeters. And also the set for filtration purposes a minimum thickness of 600 millimeters with effective size of 0.4 millimeters. So these were the specifications of the materials which I used for my prototype. And we have the thickness of 120 millimeters and also undergrades to collect the effluent. Then with the time a smooth stick will develop due to suspended solids. And lastly, the effluent will come through this outflow pipe to storage. So this is how my prototype was operating. I'll then go through the project results. I've selected just a few water quality parameters for precision purposes because I tested a lot of them. So for the results, I'll start by turbidity. This is the graph which shows the variation of turbidity. Like for example, for week 1, the raw water turbidity was in this figure more than 500 MTUs. But overall, after 6 weeks, the residual turbidity for the rainwater was at 4 MTUs. And also the turbidity reduction percentage was 98%, which is the treatment efficiency. This is unfortunately critical. It's not very clear to me. It's a technical issue. But this is the visual appearance of the water before sedimentation, after sedimentation, and then after sedimentation. Then for total dissolved solids, these were my results. The residual TDS was 9 milligrams per liter in 6 weeks, and this graph shows how the TDS was varying with time. Also for the BOD, the overall BOD removal efficiency was 96.7% with the residual BOD of 5 mg per liter. Then for COD, these were the results. 80% reduction efficiency with the residual concentration of 5 milligrams per liter after 6 weeks. These are the results for my prototype. So I'll then go to my recommendations. I'll go through my conclusions. The first conclusion, I found that the effluent quality met all standards which have been provided by the World Health Organization for greywater reuse. And also, my second conclusion, water demand will be reduced by 35% during the semester, provided this idea has been implemented by our province in here. My third conclusion, this idea of using a vertical flow biosensor filter water for greywater treatment can also be applied at household level. That is everyone fasting here can use this method and use for head homestead. My conclusion. The first conclusion, my recommendation, I'm recommending that the University of Zimbabwe should adopt this greywater recycling on campus so as to save our finite groundwater resources. Then for upscaling purposes, I recommend this design figures. A surface loading rate of at most 1 meter cube, 1 cubic meter per meter squared per hour with a filtration time of 45 minutes. And also a filtration rate of 0.3 liters per hour for the beta-flow poison filter with a detention time of 2 hours. And also a desludging cycle for the sedimentation tank of 3 months, that is once per semester. And also a smooth skimming cycle of 5 weeks, 35 days. So the recommendations continue. My third recommendation, I'm recommending that greywater reuse provisions be integrated in new development at municipal level. That's what I recommend. Then my last recommendation, I recommend that local environmental legislation laws be enacted by our lawmakers in order to help with the treatment and reuse of greywater. So these are my recommendations. So with this, all these nice results that come out from this simple technology, just using sand and gravel to treat greywater and all the effort to meet the whole standards. Why letting it go down to the source then? Let us treat greywater as a resource, not as sewage. So we all need to recycle greywater today for a greener tomorrow. I thank you.
Thank you, ladies and gentlemen, and thank you, conference. Greywater. I have 5 minutes for questions. If there are any questions from the audience, please feel free to shoot right now. There's a Robbie Makia, please.
Thank you very much for a very interesting presentation. I think as a way forward, for most administrators, they would want to know at what cost. At the beginning, you said that this whole process was duplicated for 28 students. Towards the end, you talked about a savings of 35% of the water consumption at the university. I think you need, for the future, to have more detailed analysis of those numbers. Because as an administrator, if I'm going to benefit 28 students after a 6-week analysis, that's not a good investment of my resources. So I think as we move to the larger competition, we need to do a little bit more analysis of those numbers. It's just a suggestion. And if you allow me also, for the first presenter, I would like to suggest that she looks at the pollution ratio, because garbage produces a lot of methane gas, which in fact is much more poisonous than the tobacco burnings that we have used. So I think it's important that you also look at the pollution ratio. But it's not a substitution, but it's a reduction in the pollution poisoning. Thank you.
The deep analysis is there, but for presentation purposes, I've just displayed all this, only a glimpse of the project, because it's only 15 minutes, but thank you very much. The deep analysis is there. The cost will always depend on the end use for the treated greywater. For example, let me start by talking about the prototype. My prototype costed me $400. It was saving 28 students. But but the actual cost for an upscale system, it always depends on the end use. For example, if someone is using the effluent rainwater to flush the toilets, which are situated on the 10th floor of a hotel, you need a greater pump as compared to someone who is flushing the toilets that are downstairs. So the cost always depends, but the range is there.
Thank you very much. We have time for one more question. Yes. Was that again, ladies and gentlemen? No. Okay. So one more question. Thank you.
Thank you very much. I'm not a water expert, but the question. Looking at your study, which is looking at usage